Okay, so let's go ahead and take a look at this objective. So the idea behind this objective is we just did coterminal angles, where you're trying to figure out like what angles are the same with each other. And so we start adding like 360 and we start subtracting 360. And ultimately what we're trying to do is we're trying to find like sine, cosine, and tangent of something other than a 30, 60, 90 triangle or a 45, 45, 90 triangle. And so that's where what we call the unit circle comes into play. And we'll talk more about the unit circle when we get into a future math class. But in a sense, what we're trying to do is we're trying to find sine, cosine, and tangent of like multiples of 30 degrees, multiples of 45 degrees, multiples of 60 degrees, and then the ones that are multiple of 90. And so what we do is first just to kind of give you like a brief, real quick introduction to the unit circle. If I have a unit circle, the unit circle is a circle of radius 1. And so I can label along my x-axis some value of x, and then on the opposite side of my theta, I can name that some sort of value of y, because that would be some sort of height. Now, if I wanted to find the sine of that angle, the sine of that angle would be opposite, which is, so sine of theta would be opposite, which is y over 1. And then my cosine of theta would be adjacent over hypotenuse. Did I say it? For sine, it should be opposite over hypotenuse. And for cosine, it should be adjacent over hypotenuse. What that means is that if I were to simplify this, that means that every sine of theta can be some sort of y value on a unit circle. And then my cosine of theta can be some sort of x value. What that means is that if I have a unit circle, so my radius of my circle is 1, I can label every coordinate point as a cosine of theta, comma, a sine of theta, just like I can label it some sort of x and y coordinate. Okay, and we'll talk more about the unit circle as we get into a future math class. Your 45, 45, 90 triangle, you guys have to memorize that. So you have to memorize where what the side lengths are, where everything goes. And so just as a reminder, if I have one side length as x and the other side length is x, then I have x root 2. And what you're going to find is that I'm going to start to draw these triangles, and I am terrible unless I have my little like drawing tool on the iPad for drawing triangles. But I have 1, 1, and then you're going to see a lot of 1, 1, root 2s, 1, 1, root 2s. And so, when I do these, I get in a real good habit about trying to figure out, like, okay, I'm always going to write, it in a certain way, in a certain pattern, so in that way it's easier for me to memorize. Okay, so now we're going to construct something using reflections of a 45-degree angle. So we first start out, and I put my triangle in quadrant 1. Okay, so if I label one side as 1, then my other side is also 1 because it's a 45, 45, 90. By Pythagorean theorem, I get root 2 along my hypotenuse. So if I'm looking for sine of 45 degrees, sine of 45 degrees is 1 over root 2 because that is opposite over hypotenuse. Cosine of 45 degrees is adjacent over hypotenuse. And then the tangent is opposite over adjacent. So when I rationalize my denominator, because remember, we don't want roots in the denominator, we get root 2 over 2, and then we do it again. And you're going to start to see me now that we're kind of moving into the next section that I'm not going to start showing this, this little step here of rationalizing the denominator because we've done it a lot. So I have root 2 over 2, and then I have 1. So that's all my cosines and my sines and my tangents. And what you notice is that all the values are actually positive. So all of my trig functions are positive in quadrant 1. So sine is positive, cosine is positive, tangent is positive. That would also mean if I wanted to find my other 3 trig functions, my reciprocal functions, remember my 1 over sine, so my cosecant, my 1 over cosine, which is secant, and my 1 over tangent, which is cotangent, those would all be positive as well. Okay, so now I'm going to reflect my triangle. And so remember, we talked about, use an eraser by accident, we talked about my initial side, right? So here's my initial side. And now if I reflect, I'm actually looking at this angle here. So here's my terminal side. So my total angle from my initial side to my terminal side is 135 degrees. Okay. And so what I'm looking for is I'm looking for sine, cosine, and tangent of the angle of 135 degrees. And what we say is that by the reflections that we do, we can reduce our sine, cosine, and tangent. So sine of 135 degrees, my cosine of 135 degrees, and my tangent of 135 degrees, we can reduce all of these down to this triangle here that is in quadrant 2. So now, if I have along my x-axis, that's -1. I just posted something on our school activities Instagram, so my watch is going off. Okay, so when I'm looking at this, I am -1 along my x-axis. I am +1 along my vertical line here, and then I'm a positive √2. Regardless of whether or not I have positive or negative side lengths of my triangle, I will always have a positive hypotenuse because of the Pythagorean theorem. Okay, so the sine of 135 degrees is going to be my opposite over hypotenuse, so 1 over √2. My cosine will be negative because that's -1 over √2, which is my adjacent side. And then my opposite over adjacent will be 1 over -1. So essentially I get √2 over 2, and I get -√2 over 2, and I get -1. And if I were to look at the sine of 45 degrees, right? So let's just take sine for a second. If I look at the sine of 45 degrees and the sine of 135 degrees using Desmos, so I will have to change my Desmos to be degrees here. So if I look at the sine of 45 degrees, right, you see that it gets 0.707. And then if I did the sine of 135 degrees, I get the same exact thing. Now, the cosine one, remember the cosine one was a negative value, right? So if I did the cosine, go back here, if I do cosine of 45 degrees, which you notice is that, oops, not cosine of 4, cosine of 45 degrees, right? You get the same value, but when I do the cosine of 135 degrees, which you notice is that it's negative. So that's, just kind of proving using Desmos and the calculator how you can compute these things and get those values that we just calculated. So now if I look at what you notice about quadrant 2, let's not write in a highlighter. I do this all the time too. When I look at quadrant 2, what you notice is that sine is positive. That also means that it's reciprocal. So 1 over sine, which is cosecant, will also be positive as well. And everybody else was a negative value. Okay, so let's see what happens in quadrant 3. So I'm going to reflect again. And what you notice is that, so I'm going from, again, my initial side to my terminal side, which a positive angle goes counterclockwise. And so that's actually 180 plus 45, which is going to give me 225 degrees. So now I'm going to be finding the sine of 225, the cosine of 225, and the tangent of 225. And now my side lengths are -1 along the x part, -1 along the vertical part, and then still a positive √2. So when I do 225, that'll be a -1 over √2. My cosine will be a -1 over √2. And my tangent, though, will be -1 over -1, and I get positive. So what you notice, and I will rationalize the denominator on these, so I am technically multiplying by √2 over √2, even though I'm not actually showing that step. And so when I see this, I see, okay, well, in quadrant 3, it looks like the only thing that's positive, right, is the tangent. So in quadrant 3, tangent and the reciprocal, which is cotangent, are positive in quadrant 3. And now we go to quadrant 4. So we'll reflect one more time. All the way around here will be 315 degrees, because it will be 360 minus 45. And so I have a positive 1 along the x, I have a negative 1 along the y, and then I have a positive root 2. So now when I look at this, I'll take the sine of 45 degrees. And so the sine of 45 degrees is negative 1 over root 2. The cosine of 45 degrees will be positive 1 over root 2. And then the tangent, oh, sorry, it shouldn't be 45. I don't know what I'm talking about. 315. I just saw the angle measurement. So it's 315, which is negative 1 over 1. So this is a negative root 2 over 2, a positive root 2 over 2, and a negative 1. So what you notice is that in quadrant 4, my cosine and my secant are positive, and secant being 1 over cosine. And so you're starting to see a little bit, you're like, oh, well, one quadrant, the sine is positive. One quadrant, the tangent is positive. One quadrant, the cosine is positive. And in another quadrant, everybody's positive. So now when we go and simplify this, so let's go ahead and take a look. We're going to look at the 30, 60, 90 and see what patterns we see there. So my opposite side of my 30 degrees is a 1. And a root 3 and a 2. And what you're going to notice is that I draw my triangle the same way every single time, because the adjacent side of the 30-degree angle is the one that has the root 3. So they kind of like, I think about them like kind of matching. I'm kind of terrible at memorizing things. So I'm like, oh, the adjacent side of the 30 degrees is really close to where the, where the 3's are, so that the root, the 3's kind of line up. I don't know. Maybe there's a better way of memorizing it. Okay, so let's look at, and this is where I have some weirdo like typos, so I'll have to like fix those for you guys. I don't know, we have like floating ones and question marks and all over the place, so that I forgot to delete. Okay, so we start off with this first one, which is already wrong. The adjacent side of the 30-degree angle is the root 3 side, and then it is a 1 and a 2. So I want to find the cosine, sine, and tangent of 30 degrees. So sine of 30, cosine of 30, and tangent of 30. So now when I look at the cosine, the sine of 30, which is opposite over hypotenuse, the cosine of 30, which is root 3 over 2, which is the adjacent over hypotenuse, and then I have my tangent, which is 1 over root 3. So the only one I need to rationalize is the root 3 over 3 one. And what you notice is that in quadrant 1, again, just like with the 45, 45, 90, is that all trig functions are positive. All are positive. Meaning my sine and its reciprocal, which is cosecant, my cosine and its reciprocal, which is secant, and my tangent and its reciprocal, which is cotangent. Those are all positive, okay? I'm going to reflect again. That should have been a root 3. I'm going to reflect again. That should be a 2. And I get a root 3 along the bottom, but that is negative. And I get a 1 across the top, which is a positive because I'm still above the x-axis. And then I have my 2. My angle measurement all the way around, though, here is 90 plus 60. So it is... No, it's 180 minus 30, which is 150 degrees. Or 90 plus 60, I was right to begin with. It's been a long day. Okay, so we're going to do sine of 150 degrees, cosine of 150 degrees, and tangent of 150 degrees. Okay, so again, to find that 150 degrees, I took my initial side. I have my terminal side here, and then I took 90 degrees, which is along my positive y-axis, and that's a 30 here, so then that makes that 60 there, so that's why I did the 90 and the 60 and added them together. Okay, so now my sine of 150, so looking at the sine of this 30-degree angle here, which is a positive 1/2. My cosine is a negative root 3 over 2, and my tangent is a 1 over negative root 3. So I get a negative root 3 over 3, and that's the only one I need to rationalize. Again, you'll recognize in quadrant 2 that sine and its reciprocal, which is going to be cosecant, are both positive. I don't need to do that. Are both positive, if I could spell. Okay, and everybody else will be negative. And so now we keep going, and hopefully you're going to start to see a pattern, and there is a pattern. We'll talk about that. But now, again, that's supposed to be a root 3. Negative root 3 is along here. Negative 1 is along the vertical part, and then 2 is across the hypotenuse. And so again, sine, cosine, and tangent, but I'm going all the way around, which is 180 degrees plus 30, which is 210. So I want the sine of 210 degrees, I want the cosine of 210 degrees, and I want the tangent of 210 degrees. And what you should notice is that they all reduce down to a 30, 60, 90 triangle. The only difference is that which one's positive and which one's negative, right? And if you remember from the 45, 45, 90 triangle, that in quadrant 3, we had tangent and its reciprocal, which is cotangent, that were both positive. So now, when I look at sine of 30 degrees will be a negative 1/2. My cosine is negative root 3 over 2. And lo and behold, we have negative 1 over negative root 3, which just turns into a positive root 3 over 3. So in quadrant 3, tangent and cotangent are positive in that quadrant. Okay, so now we're going to go all the way into quadrant 4, so all the way around here, which is going to be 360 minus 30, which is 330. So I'm looking at the sine of 330, the cosine of 330, and the tangent of 330. And again, this should have been the root 3 side. That should be the one side, which is negative, and a 2. So then my sine is going to be negative 1/2. My cosine is going to be a positive root 3 over 2, and my tangent is going to be a negative 1 over root 3, which is negative root 3 over 3. And just like before, the fourth quadrant, my cosine and my secant are positive, and everybody else was negative. So you should start to see a pattern. Okay, so now it's time to look at the 60-degree angle measurement. And so you should see a pattern. We've done the 45, 45, 90. We did everything related to a 30-degree angle. So it should be the same for when we do 60 degrees. So in quadrant 1, all of them should be positive. So I have my 1 side, my root 3 side, and my 2 side. So I have the sine of 60 degrees, which is root 3 over 2. My cosine of 60 degrees, which is 1/2. And it's all weird. My tangent of 60 degrees is equal to root 3 over 1, which is just root 3. Okay? And all of them, again, are positive. Now, when I go into quadrant 2, my whole angle measurement, I was going to say reference angle, but that's not true. I start from my initial side again to my terminal side again, and I have 90, and then this little angle is 30, so the whole thing is 120 degrees. So now I'm looking at the sine of 120, the cosine of 120, and the tangent of 120. What we're doing right now is really we're reducing our 120 degrees into something that fits a triangle. And so this angle of 60 degrees is called my reference angle. So I can use that to determine what my triangle is that I'm looking at. And then what I can do is I can use the fact that I'm figuring out like whether all are positive in quadrant 1 or in quadrant 2. You should see sine as positive and everybody else is negative. But you can reduce these down pretty quickly without a calculator. But again, if something doesn't work into a 30, 60, 90, or 45, 45, 90, I'd have to have you guys use a calculator for it. Okay, so now 120 degrees, so the sine is going to be root 3 over 2. And then I'll have a negative 1/2, and then I'll have a negative root 3. So again, sine and its reciprocal are positive in quadrant 3. Now, going all the way around here, this will give me 180 degrees plus 60, which is 240. So now I want sine of 240, cosine of 240, and tangent of 240. And so I will have a negative 1 here, a negative root 3, a positive 2. Again, it's positive 2 because of the Pythagorean theorem. It has to be a positive hypotenuse. Okay, so let's see, 240 degrees, so that is opposite, which is negative root 3 over 2. And then I have negative 1/2. And then I have a negative root 3 over negative 1, which is a positive root 3. So again, in quadrant 3, tangent and cotangent are positive, and everybody else was negative. Okay. All the way around here will be 360 minus 60, so 300 degrees. So we're doing sine of 300, cosine of 300, and tangent of 300. So now when we look at this, it's a negative root 3 along my vertical part and 2. So my sine of 300 is negative root 3 over 2. My cosine is a positive 1/2, and my tangent is a negative root 3. So in quadrant 4, cosine and secant are positive. So what you noticed is that in quadrant 1, all trig functions were positive. And then in quadrant 2, sine and cosecant are positive. And then in quadrant 3, we have tangent and cotangent are positive. And then in quadrant, oh my goodness, in quadrant, my pencil is like acting up. Okay, in quadrant 4, cosine and secant are positive. So there's a couple ways that we can memorize this because we have to memorize everything. All the science people get all the definitions and we get nothing. So we can memorize it with all students take calculus. Or Mr. Mondragon's like way of doing it is all sad turtles cry, which he totally made me like a sweatshirt that has that on there. Okay, so the A stands for all, the S stands for sine, and then the T stands for tangent, and the C stands for cosine, and those letters are the first thing that, you know, the first letter of those words will tell you which one is positive. Okay. Now, what you notice is that, like, all of my bigger angles, right, had a smaller reference angle here, which is 60 degrees. So I am going to have to find what we call reference angles, and there's a way to do that. First, you have to make the angle positive. So whatever angle measurement you're given, you have to make it positive. If it's negative, add 360 degrees until you get a positive angle. If you have an angle that's bigger than 360 degrees, then subtract 360 degrees in order to get an angle that's between 0 and 360. So if the given angle is positive, you have an option 1 of it is less than 360 degrees, or it is bigger than 360 degrees. And if it's bigger, then you're going to subtract 360 to get it to be smaller. If it's less than 360 degrees, then if your angle is in quadrant 1, the reference angle is itself. If you're in quadrant 2, the reference angle is 180 minus the angle measurement. If you're in quadrant 3, it is the angle measurement minus 180. And if it is in quadrant 4, it is 360 degrees minus the angle. If the given angle is negative, then you add 360 degrees until it is positive. Okay. All right, so if I want to find the reference angle for 220 degrees, I'm going to use this little formula thing that we have here. So 220 is in quadrant 3. So that it is the angle measurement, which is 220 degrees minus 180. And so you get 40 degrees. Now, if you're 342, I have to take my negative 342, and I take and add 360 to it. So that gives me 18. That is in quadrant 1, so 18 is my reference angle because in quadrant 1 it's itself. Okay. Now, I'm going to use the unit circle, so I'm going to make a circle of radius 1 to show you what the values are for all your 90-degree angle measurements. So if I'm on 0 degrees, this coordinate point that's a question mark is 1, 0. What that means is that here, if I were to change this, this means that the cosine of 0 is equal to 1, and the sine of 0 is equal to 0. That's what that coordinate point means. So my cosine is equal to 1, and my sine is equal to 0. Then I go to my 90 degrees, and that is 0, 1. So my cosine of 90 degrees is equal to 0, and my sine of 90 degrees is equal to 1. 180 degrees is negative 1, 0. So my cosine of 180, and then it's all weird. My cosine of 180 and my sine of 180. So my cosine of 180 is negative 1, and then it's 0 for sine. And then I have 0, negative 1. And so I have my cosine of 270 degrees and my sine of 270 degrees. So then that is 0. Oops, no, just kidding. 0 for my cosine and negative 1 for my sine. And then 360 degrees is back to what we had for 0 degrees. Okay. Now, in order to find all my other trig functions, I have to do my ratio. So my tangent is the same thing as sine over cosine. So now I have 0 over 1, which is 0, 1 over 0, which is undefined. And then I have 180 degrees, which is 0, and then I have undefined again. And then I have 0. When I do cosecant, that is 1 over sine of theta, so then 1 over sine, so that is undefined. And then it is 1, and then undefined, and then 1, and it should be negative 1, and then undefined again. And then my secant is 1 over cosine. So that is 1, and then that's undefined. And then that is negative 1, and then undefined. And then 1. And then my cotangent is going to be cosine over sine. Oh my goodness. Cosine over sine. So that is undefined. 0, undefined. 0, and undefined. So now, if I do this without a calculator, okay, so my 210 degrees, and I want to find out what sine is of 210 degrees. So what I'm going to do is step 1. Am I between 0 and 360 degrees? The answer is yes. Then my next question is 210 degrees is in which quadrant? And in this case, 210 degrees, which in all cases, it's in quadrant 3. And then, is my sign positive or negative in quadrant 3? It is negative. Then I have to find my reference angles. So my reference angle, because I'm in quadrant 3, is 210 minus 180, which is 30. And then I rewrite it. So I take sine of 210 degrees, and that's the same thing as a negative sine of 30 degrees. So now that requires me to draw my triangle, 30, 60, 90, root 3, 1, and 2. So the sine of 30 degrees is negative. It'll be negative 1/2 because of the negative sign out in front here. Okay. Step 1, between 0 and 360, the answer to that is no. So I have to take my 360 and I have to add it to a negative 390. So I get a negative 30, and then I add 360 again, and I get 330. So now what I'm looking at is the tangent of 330 degrees. Step 2, 330 is in which quadrant? It is in quadrant 4. Is tangent positive or negative? Because I'm looking for tangent. Is tangent positive or negative in quadrant 4? It is negative. Then I find my reference angles, and because I am in quadrant, because I am in quadrant 4, I have to take my 360 and subtract 330, which is 30. And my pencil's being all weirdo. And then now I have tangent of negative 390 is the same thing as the tangent of 330, which is the same thing as negative tangent of 30 degrees. And when I look at my triangle, the tangent of 30 is opposite over adjacent, and then I rationalize my denominator, and I get a negative root 3 over 3. And now we're going to look at secant. So am I between 0 and 360? Yes. My second step is where's 315? That is in quadrant 4. My third step is secant positive or negative in quadrant 4? It is positive because it is 1 over cosine. Then I need to find my reference angles, or reference angle, and that is 360 minus 315, which is equal to 45. So now I have the secant of 315 degrees is equal to the positive secant of 45 degrees, which we do not have a 45, 45, 90 triangle. You might not need to write them because you might be able to remember them. And my secant is root 2 over 1, which is just the square root of 2. Okay. Now, when we do this thing about which quadrant am I in, I have to, it's like those like weirdo, like back in the day, those Venn diagrams that you guys did. I wouldn't say they're weird, but I always thought that they were like sometimes confusing. What I want is the overlapped thing. So what it has to meet both things. Okay. So my sign has to be less than 0. Well, sign is positive in quadrants 1 and 2, and so it's negative in 3 and 4. And then my cotangent is bigger than 0. That is in quadrant 1, right? And then that's also in quadrant 3. So where am I start in both quadrants is in quadrant 3. Because remember, I wanted sign to be less than 0. So these positive ones don't matter for my sign. So they have to both work, and that only happens in quadrant 3. Okay, and that is it for this lesson.